Hello, welcome to a presentation on the textures of igneous rocks. First of all, we have to define an igneous rock and what a texture is also have to be defined. As you know that igneous rocks are made up of glass, crystals and fragments of glass or crystals. So, an igneous rock may be made up of crystals only or glass only or a combination of these. Texture is the characteristic interrelationship among these materials, including the grain size, shape of the grains, alignment of the grains, that is the orientation of the grains, boundary relations among different mineral grains and the degree of crystallization of the rock. So, texture will include all these aspects. Structure on the other hand embodies the material relations of groups or aggregates of grains such as bedding or folds in bedding. So, it means that structure is a large scale feature, whereas texture is a small scale feature. We have to distinguish between texture and structure. As you see that textures provide direct evidence of the conditions of the origin of the rock. In fact, you will find that a time was there when only textures were available to give an idea about the genesis of these rocks. So, texture will be studied in hand specimens and also in thin sections, whereas structure will be studied in the outcrops of rocks. Let us see the texture of igneous rocks. How do we describe the texture of igneous rocks? We have to consider the following factors in describing the texture of igneous rocks. These three factors are crystallinity, granularity and fabric. Crystallinity indicates the degree of crystallization of the magma, that is a rock is formed, an igneous rock is formed by the crystallization of a magma or a lava. So, how much crystallization has taken place in the formation of these rocks? Granularity tells about the absolute size of mineral grains, how big the mineral grains are or how small the mineral grains are, whereas a fabric shows the shape of mineral grains and the mutual relation of the mineral grains and glassy matter in an igneous rock. As already mentioned, textures are better studied in hand specimens and in thin sections. With the help of in thin sections, we have to study them under a petrological microscope. First, let us see crystallinity. As already mentioned, it is the degree of crystallization, how much crystals have been formed from a magma or lava. There are three kinds of igneous rocks, igneous textures based on crystallinity. They are holocrystalline, merocrystalline and holohyaline. Holocrystalline means the entire rock is made up of crystals. These may be phanerocrystalline or microcrystalline. Phanerocrystalline means that the grains are visible to the naked eye or grains can be seen with the help of a hand lens, whereas microcrystalline means the entire rock is made up of crystals, but these crystals are small and can be seen only with the help of a microscope. Mesocrystalline on the other hand shows that the rock is partly made up of crystals and partly made up of glassy material. Then the third type, holohyaline, tells about the rock being completely made up of glassy material. Glassy material in the sense that there is no crystalline substance. The material constituting the rock will not show any internal structure for each and every part. Now, we have some photographs of holocrystalline texture. this is a specimen of granite which is holocrystalline. We can see the individual grains here. We have feldspars, quartz and mica shown here. The black one are micas, maybe some of them are hornblende, and the white or dull white they are quartz and feldspars. This is a holocrystalline texture shown in thin section, being seen under the microscope, under a petrological microscope. Here you have all the part of the rock is made up of crystals. You can see different crystals there. You have feldspars, then some opaque minerals are also there. Quartz is also seen. This is a photograph showing a hypo or mirrocrystalline texture in thin section. Here you can see some part of the rock is glassy, which is opaque, whereas some are made up of larger crystals and some are smaller crystals. This is an example of holohyaline texture, in which the entire rock is made up of glassy material. This is a specimen of obsidian glassy material. Here again in thin section holohyaline texture is seen. There in this rock you can see some cracks. These cracks are called as pearlitic cracks. Pearlitic cracks are characteristic of this glassy material. Glassy material can be identified in thin section, because you will find that they will not allow the polarized light to pass through. In crossed nickels, they will appear totally dark under crossed nickels. The second criterion is granularity. Granularity indicates the absolute size of mineral grains present in a rock. A rock may consist of feldspar, quartz, micas, amphiboles, pyroxenes, etc. And we have to see the size of these mineral grains. There are two major categories of granularity. One is called phaneric. Grains can be identified with the help of a hand lens, or even with naked eye we will be able to identify the mineral grains. So, based on the size of the individual grains, four types of granularity can be seen, textures can be seen. They are fine grained. The grain size will be between it will be less than 1 millimeter in diameter. The best example is dunite, a rock which is fully made up of olivine. Almost more than 90% of the rock is made up of olivine grains. It has a sugary appearance. The second type is called medium grained texture. Here the grain size falls between 1 mm and 5 mm. The best example is diorite, which contains a large proportion of plagioclase feldspar. The third category is coarse grained texture. Here the grains are between 5 mm and 3 centimeter in diameter. We have gabbro as the best example. Gabbro is made up of clinopyroxenes and calcic plagioclase feldspar. The last one, that is the fourth variety, is called very coarse grained texture, which has grains that are more than 3 centimeter in diameter. The best example is pegmatite. Pegmatite, when somebody says pegmatite, that term itself shows that it is a very coarse grained rock. So, we have different types of pegmatites. These pegmatites include granite pegmatite, cyanide pegmatite, diorite pegmatite, gabbroic pegmatite, etc. So, thus phaneric rocks show four types of textures: fine grained, medium grained, coarse grained and very coarse grained. The second major category is called aphanitic texture. Here the grains cannot be identified by unaided eye. We have to depend on petrological microscopes for the identification of grains. Even with that, it will be difficult to make out. Advanced microscopes are required with high magnification are required for the identification of mineral grains. Here obsidian is a typical example of aphanitic rock. You have photographs shown here of exemplifying phaneric texture. Anorthosite in hand specimen is shown here. Anorthosite is made up of a mineral called mainly labradorite, a variety of calcic plagioclase. So, this is a specimen of anorthosite which is almost fully made up of plagioclase feldspar. Here you have a rhyolite showing fine grain texture. Rhyolite is the volcanic equivalent of granite. Here the grains are very small. Maybe we can identify some of the phenocrysts that are present, larger grains present. We will explain what a phenocryst is in the later part of this presentation. The coarse grain rock, this is a granite showing a hand specimen of granite showing feldspars and some feldspars, quartz and some dark ferromagnesian minerals. Very coarse grain, this is a pegmatite, pink feldspar pegmatite with mica. Mostly biotite is the dark colored mineral there, quartz and pink feldspar are present. The grains are very large. It has a granitic composition, hence we call it as a granitic pegmatite. Composition is granitic, size of the grains is large, more than 3 centimeter. Many of the grains are having diameter more than 3 centimeter. Therefore, it is called a pegmatite and it is a very coarse grained rock. Aphanitic texture in hand specimen. Here you see that only some small grains are seen, larger grains are very small in number, whereas the other grains cannot be seen with the naked eye. So, the third major criterion is fabric of the rock. Fabric refers to the shape of the grains and mutual relationship among the grains with respect to glass, if any, in an igneous rock. It is not a must that every igneous rock contains glassy material. Some of the, as we have seen that holocrystalline rocks do not contain any glassy material at all. So, we have to study the shape of the grains and the mutual relationship among grains with respect to glass in an igneous rock. Based on the development of crystal phases, 3 types of grains can be seen in an igneous rock. These 3 types of grains are called euhedral, subhedral and anhedral grains. Euhedral grain means the grains are completely bounded by their own crystal phases. These are early formed crystals from a magma. So, we find that normally the early formed crystals are that of accessory minerals. For example, magnetite, if it is formed, they will be of early formed. Calcic plagioclase, again it is early formed, or pyroxenes, these are early formed minerals. Subhedral means grains are only partially bounded by crystal phases, which means that part of the side of the grains will be covered by some other grains which will not reflect any phase at all. Anhedral means grains are completely devoid of their own crystal phases. It does not mean that the grains are non-crystalline. Only thing is that these grains have formed probably as the last one, or they have formed from a magma which has cooled very rapidly. So, the form of these anhedral grains is determined by the shape of the surrounding grains. So, after the formation of all the other grains, if some other mineral forms, the vacant spaces will be filled by the remaining solution, the crystallization of the remaining magma, and that takes the shape of the vacant spaces left by other minerals. So, these minerals have irregular shape. Thus, we have 3 types of grains in igneous rocks: euhedral, subhedral and anhedral. So, here we have diagrams representing these 3 types of crystals. Anhedral crystals are shown as the first one, followed by subhedral crystals. You can make out some phases there, and some part of the crystal is covered with some other mineral which does not show the phase at all. Whereas, the third type, euhedral crystal, there you have the well developed phases. All the entire crystal is made up of well developed phases. Thus, we have 3 types of crystals seen in igneous rocks. Now, we have mineral representatives of euhedral, subhedral and anhedral crystals. The first one is that of corundum. Corundum grains are shown, of corundum of different colors are shown. Corundum is an early formed mineral from a magma. So, here you see well developed crystals of corundum. Then we have subhedral crystals. There you have some of the phases can be seen. Anhedral crystals are also seen, is the last one, where you are not able to see the development of any phase at all. So, fabric, continuing our discussion on fabric, we find that the mutual relationship among grains and glass have to be described in fabric. Based on that, many types of igneous textures are distinguished. The major types are equigranular texture or granular texture and inequigranular texture. In equigranular texture, we will find that most of the mineral grains are of nearly equal size, it gives a granular aspect to the rock. So, we find that when we examine a rock in hand specimen or thin section, we will find that most of the grains are of a similar size, then we will say that that texture is called equigranular texture or granular texture. Inequigranular texture means the grains are of different size in the rock, that gives rise to inequigranular texture. So, there are different varieties of equigranular or granular textures. These are mainly 3 types. They are called as hypodiomorphic texture, hypodiomorphic granular texture, allotriomorphic granular and panadiomorphic granular. So, in the case of hypodiomorphic granular, some grains are euhedral, some are subhedral and the rest are anhedral. That is, when a rock is formed from a magma, the earliest formed minerals will be if uniform cooling of the magma takes place, the early formed minerals will be euhedral and those are the intermediate stage will be subhedral, and the last stage, at the last stage of cooling of the magma, you have the vacant spaces filled with the crystallization of minerals, that will give rise to anhedral minerals. So, a combination of euhedral, subhedral and anhedral grains gives the hypodiomorphic granular texture. The best examples are given by acid rocks, acid or intermediate plutonic rocks like granites, cyanides and diorites, they give this hypodiomorphic granular texture. The best example is granite. Remember that all acid rocks will not give, only plutonic igneous rocks, plutonic igneous rocks of acid or intermediate composition will show this texture. Volcanic rocks will not show this texture. Allotriomorphic granular, here most of the grains are anhedral. So, the majority of the grains they do not show crystal phases at all. This is exemplified by the rock apatite, which is a hypabyssal rock, and some ultra basic rocks are also showing this sort of texture, allotriomorphic textures, and some basic plutonic rocks also show this allotriomorphic texture. The third variety is called panadiomorphic granular texture. Here majority of the grains are euhedral and maybe of very similar size. This is typical of the rock lambrophyre. So, these are the 3 types of equigranular texture or equigranular or granular texture. Now, we have a figure showing the hand specimen of a figure of a equigranular texture showing, and it is holocrystalline, it is a holocrystalline rock. Here you can see that the grains are more or less of equal size or similar size. Equigranular texture in hand specimen, that again shows a number of grains, maybe quartz, feldspar is there, and some dark minerals, maybe amphibole and mica. Again, a photograph showing equigranular texture containing quartz, feldspar and mica here. This is hypodomorphic granular texture shown in thin section, where you find that the grains are larger in size and are of similar size. Allotromorphic texture, the grains are small and we are not able to see, they are of equal size, but we are not able to see the faces of the grains present in this is in hand specimen. Well, thin section shows allotromorphic texture, where you find a number of grains, but most of the grains do not show crystal faces. Their boundaries are marked by the presence of the boundaries of other minerals. Panadeomorphic texture in hand specimen, which is very, it is a rock showing panadeomorphic texture, and the grains are of equal size, and many of them, because of the smaller size, we are not able to see the crystal faces yet, but they are of equal size and they have well developed crystal faces. This is a typical example of a lamprey showing well developed faces, more or less of similar size, and this is panadeomorphic texture in thin section. Well, in equigranular texture, we have seen equigranular texture. Now it is the time for discussing inequigranular textures. There are three types of textures here. It is called the first one is called seriate texture, the second is called porphyritic texture, and the third one is called poikilotic texture. Seriate texture means it is a texture in which the crystals vary gradually in size from the smallest to the largest. So, we will say there is no sudden change in the size of the grains. So, there is a gradual change in the size of the grains present in the rock, that is called as a seriate texture. The second one is called porphyritic texture. Here there is large variation in the size of the grains. We will find that very large grains are found in a fine grained what is called as ground mass. So, a ground mass encloses larger grains. The larger crystals will be called as phenocrysts, and the ground mass is made up of smaller grains. The normally minerals like cyanite, diorite, peridotite, they show this sort of porphyritic texture. Even granites show porphyritic texture. The third variety is called poikilotic texture. It is a texture in which small crystals of one or more minerals are irregularly scattered in an anhedral larger crystal of differing composition. So, there are two types of crystals present. Let us call crystals of A and crystals of B, and crystals of A will enclose large crystals of A will enclose smaller crystals of B. That will be called as poikilotic texture. This can be seen in some hand specimens also. Cyanite, peridotite are examples of rocks showing poikilotic texture. So, inequigranular textures are of three types: seriate, porphyritic and poikilotic texture. So, here we have porphyritic texture shown. You can see the larger grains, which are called as phenocrysts. They are embedded in a ground mass which is made up of very small grains. Sometimes it may be made up of glassy material. So, there is a large scale difference in the size from phenocryst to the one in the ground mass. Porphyritic texture in hand specimen, it is earlier one was in a figure. This is the one shown in a hand specimen. You can make out larger grains of feldspars enclosed or embedded in a matrix, in a ground mass of quartz, feldspar and some dark minerals, maybe biotite or some amphibole or pyroxenes. Here again it is a hand specimen of showing a typical porphyritic texture. The phenocrysts are feldspars and the ground mass is made up of feldspars and some dark colored minerals. You can see the large variation in grain size from the phenocryst to that present in the ground mass. Here again we have an example of porphyritic texture shown in thin section. You can see large pieces of feldspars that found in a ground mass, which is made up of maybe you have some ferromagnesium minerals are there, some feldspars are there. So, they form the ground mass and you have large phenocryst feldspars which are found in the ground mass. This is a poikilotic texture in thin section. We have here large plates of augite, a pyroxene. That green colored mineral is augite, which is enclosing small laths of plagioclase feldspar. We can see the larger grains of augite enclosing smaller grains of plagioclase feldspar, that is a poikilotic texture. So, here you find that we have discussed a series of textures, which tells about the nature of the rock. These textures are due to the various factors which we have discussed, that is you have the crystallinity, granularity and fabric. In fact, fabric has to be discussed further, that we will do it in the next presentation. So, identifying the texture will tell us so much about the genesis of the rock. As I told in the beginning, these textures will indicate the nature of cooling of the rock and also give an idea about the composition of the magma and viscosity of the magma, etc., which these things which we will discuss in the second part of the presentation. Thank you very much.